Hi, everyone.
Sandeep.
Hello.
All right, I think it's almost everyone, and I think we might give it an early start. Now, as Jose Luis does from the GST, he introduces every talk with a warm welcome. So, hello everyone, in the spirit of Jose. Welcome to the workshop. I'll share my screen and give a little overview of the workshop for those who are also joining on YouTube. And then we will start with a great talk this morning by Nono Martinez Alonso, followed by the workshop on 2D applications with later on. I'll just share my screen briefly. Swap. So just a recap for the week for the participants as well. Today we'll have this great lecture followed by the workshop. Tomorrow we'll be having a guest lecture by Jia Zhang, an Irving Fellow, and be looking at the 3D applications. Thursday we may have Jose's lecture, which was postponed. That's yet to be confirmed. And Friday we have Charles Walden, followed by the final student presentations. Just a little bit of housekeeping. Do use the tech support in the Discord. We have our own great channel, and use this to definitely share your work and form some teams. Today's handout is handout 3. That's for the workshop later on. And I'll stop sharing. Now with that, I'm happy to, if the participants would be comfortable in turning their cameras on. I think it's always helpful, even for Nono in his presentation, just to see some warm faces. It's always a little challenging on Zoom with these things, but I'm sure he would appreciate that.
Yep.
So I'll briefly introduce Nono, and then we'll get into it. So welcome, Nono. Thanks so much for coming today. I imagine that many of you surely would know him by now. He's been quite a prolific voice in development of open source teaching relating to machine learning and creative coding. Now, just a few words about him. He graduated from the Harvard Graduate School of Design with a Master in Design Studies in Technology, 2017, after completing some architectural studies in North Carolina and Sydney. He also worked at ARMA and Foster & Partners, and for several years now, he's been working as a machine learning engineer at Autodesk. We did invite Nono today to keep his Autodesk hat off, unless, of course, he's happy to share some of the work he's been doing, and we're excited nonetheless to hear some of his work. And we invite him to share some of these works and his thoughts relating to this topic of the workshop. So it's machine intelligence and architecture Turing test. What has been so great to see in Nono's work is really his passion in using these technologies to create more meaningful, creative, and simple lives. And these are topics which certainly come across in his podcasts, sketches, weekly YouTube live streams, and I'm sure we'll get a taste of these today. Just a bit of housekeeping before we start. Participants, feel free to post any questions in the chat, and those on YouTube as well. We can read those out later, and we'll have a very brief Q&A so right after the talk. So looking forward to it. Thanks again, Nono.
Yeah, thank you. Just let me know if you can hear me. I'm gonna share screen just to test that everything's working. And I would also appreciate if everyone can mute themselves so I can hear some noise. So that would be also good. Okay. Yeah, so are you guys, just a quick question, are you guys able to mute participants? Just because, okay, sounds good. Okay, I'll get going then and share. All right, so just quick confirmation. Let me know if you can see the intentionally left blank and that you can hear me okay.
Perfect.
Awesome. Cool. Awesome. And yeah, I'm going to be recording on my end as well. So I'll be recording myself and my slides, and later, we have these live, so it doesn't really matter. It will be there. And I'll upload this presentation to YouTube also on my channel that I'll comment on in a second. And if we have time, as George has mentioned, I'd love to have a brief discussion with you guys, mainly hearing comments or questions that you have on the topics that I'm going to present, because I'm putting together a potential episode on the Getting Simple podcast. And, if you talk, if you give me your consent or something, I'll be happy to maybe even read what you say, or like even put the audio later. So that, just keep in mind that's something open, and I'm not gonna just post it. I'll ask for consent before we do that. All right, so let me see if this works really quickly. Seems like something is going pretty slow on my end right now, so I'm not sure if like recording locally and sharing to Zoom is a problem. Yeah, is that slow?
It is a little bit slow.
It is, right? So the animations are a bit slow. Okay. Yeah, maybe I'm gonna have to stop recording on my end or something. Let me just double check here what's going on. Okay, let's try once again. If it doesn't go faster, I can probably stop recording on my end. Yeah, it's a bit slow.
We can share the recording with you after as well.
Yeah, let me just double check one part of it. So what about this one? I'm gonna play a video, like a test video, just make sure. Can you hear audio? Is that a bit more fluid?
I cannot hear audio, and I'm not sure if it's meant to be fluid, or maybe that's the animation.
Yeah. Okay. Well, okay, share sound optimized for video. Yeah, let's try. I'm not sure how this is gonna play, but I'll just try it. Otherwise, I'll stop. All right.
No, we do see like the Zoom function bar floating in the middle of your screen. Okay, now it's done. Now it's gone.
So now you're still at the first slide right now, right?
Yep.
Okay, I'm gonna get started and we'll see how it goes. So, hi everyone, it's Nono here. And the first thing that I would like to do is to thank you guys, so Runja, George, and Dong Yung, for inviting me today and the opportunity to share my work once again here. And also thank everyone who's attending the lecture, and also if you're watching online or you're watching a recording, thanks for being there, and thanks. I'll be really glad to hear your comments, suggestions, or questions. My name, as George said, is Nono Martinez Alonso, and today I'm going to talk about kind of a conceptual frame that I'm trying to develop that is called Drawing with Constraints. And I'll show creative and collaborative interfaces that me, myself, and other people have done to produce drawings and designs, and to kind of think about how interfaces in general inform what we create as, creatives. Before I get started, I'll reiterate a bit of the things, or maybe summarize a bit of the things that George mentioned about myself. I'm Nono Martinez Alonso. I studied architecture, but something crucial, I think, on my career is that I started teaching myself programming at age 13 or 14. I got hooked by the internet and making websites, and that has ended up defining my career. I didn't know I didn't know that. So let me just see. I just got like a notification there in the middle saying that the recording was pressed. Okay. So yeah, I think that really defined my career in a way that I didn't expect, because I started programming just because it was fun, and today I can make a living out of it. I came back to my hometown in Malaga, Spain 3 years ago. I spent some time in Cambridge studying a master's in technology, in design technology at the Harvard Graduate School of Design, where I specialized in computational design to create these so-called intuitive interfaces and hopefully learn how to make hard technologies accessible to a public that is not non-technical. I work as a machine learning engineer as well at Autodesk, and as a disclaimer, today all the views that I'm showing are my own, and I'm presenting personal projects only. I'll provide more information at the end of the talk of where you can find some of the things I'm going to mention, but you can see at the bottom right of the screen there is a QR code, so you can go there. There's going to be a detailed list of links. I'm not sure if it's up to date, but it will after the talk. And I'm going to share part of my main 3 passion projects, as I call them. I live stream and record videos on creative coding, machine learning, and more, like things like podcasting, art, and writing on Thursdays around 12 to 2 p.m. EST. I also host the Getting Simple podcast, which is kind of my pet project that features conversations with creatives from eclectic areas, and is available wherever you get your podcasts and also on YouTube. And I publish a weekly newsletter with stories and sketches that goes out every Tuesday. And I believe like maybe 15 minutes ago, there was a post that went out that was scheduled. So I'll invite you to share or tweet about anything of the things I mentioned today. I'm on Instagram, Twitter, and Facebook as NonoESP, and on YouTube as Nono Martinez Alonso. So yeah, let's get started. In a workshop in Toronto with José Luis García del Castillo, we tried to provide participants with access to different technologies, right? We created programs or interfaces that we thought would let our participants or collaborators interact in easier ways with robots, right? To draw, for instance, or even use an artificial intelligence, like the structure you can see in blue, autocomplete a drawing using something in this case called SketchRNN. We also explore using image classification to control a robot, and here's Jose Luis controlling a robot with arm gestures. And here I'm using object detection to generate machine instructions according to the position of an orange on my webcam. A recent technology that I'm exploring is auto-embroidery machines. As I'll comment later, I love hand sketching from reality. And in this project, I wanted to explore hand sketching on a digital medium and have the machine embroider my designs. This is the remarkable 2 tablet in which I was drawing and then getting the drawing and simplifying it on Illustrator, generating an embroidery file in processing with pembroider, and then printing the designs with an Alpha Duo, which is the equivalent of a 3D printer for threading or embroidering. Pembroidering, just as a shout out, is an awesome open source library made by wonderful people that you should check out. Their group is called Creative Inquiry, and I believe it's led by Golan Levin. Here are some of my first tests that remind me of some of the tests that I did when I was learning how to tweak 3D printers with G-code. And this is a preview of the thread path in processing, right? And these, there are multiple softwares for these sort of file types, and this one just previews how the path will print. And this is a short video of the actual embroidering process, right? It's not easy, I would say, to make it work properly. The thread or the needle breaks many times and there are many failures. So I'm just showing here one of the ones that works the best. And then you have to cut the thread, and then at the end you cut the fabric, and you can even watercolor on top of it. So we've seen a transition happen in which we went from doing things manually to mechanically to digitally, and now we're transitioning toward intelligence, right? To the interface is somehow evaporating, and you can think of writing as an example, like you write with a pen, then with a mechanical typewriter, then with a laptop or like a cell phone, and then you can even have voice commands that let you interact with the machine. We automated everything that we could with electricity, and now we're about to add intelligence to those same things. And this transition also happened in the AC industry. the question is, why is this change important to the design field? I believe it's because the interfaces and interactions available to us determine to a high extent how we design. And there's somebody unmuted. Sorry for that. Okay. But why is this change important to the design field? So I believe it's because the interfaces and interactions available to us determine to a high extent how we design. Other people are developing interfaces that we end up using, and what happens with that is that we don't define how we want to create or the ways in which our profession or our discipline actually is meant to create, right? We used to use pencil and paper to sketch, and we've gone from doing something like this with our hands, in which you were free to kind of wiggle around, to doing this with a computer. With just 2 clicks, you draw the line and digitize it. Today, we can define buildings with data, as you might have been doing already with different programs, and don't even draw lines, but adjust the sliders and parameters. And we also use code as an interface, right? So we can have the same thing written as a line of code, and we write programs to generate drawings, designs, and buildings, and are starting to code without writing a single line of code. We're moving toward a future in which instead of writing programs, we'll train machines to help us make decisions. And for instance, a bot could learn a behavior to help us color the sketch of a house or do any other task that you can imagine in the design field. This presents a new paradigm in which we can program the machine with examples, and by creating a data set, the designer is the programmer, and choosing the right set of images becomes part of the design process. Every creative medium has implicit design constraints, and today I also want to share with you 3 interfaces in which design constraints let us be creative, but also limit what we can do. And that's not inherently bad, that's even something that's good. Forces Desktop is one of my projects at Harvard in the GSD. In 2015, I created this interface to design and interact with a structural model in which you can grow a model by suggesting the XYZ axis to the user where they can click. And you can find that it's easy to build a 3D model in a constrained but really flexible way. Right-clicking, we can fix a node structurally, and the system recalculates the structure and shows you how it will deform. As you can see in this other animation, you can push a wall by adding punctual loads and even simulating wind and other forces and how they will deform the structure, or even how a bridge would behave, which could serve, I believe, to provide an introduction to structural behavior to people who don't know anything about engineering, even for kids to start acquiring some intuition. Here's another project that I did that's called Wiggly. It's a weird app written in P5.js, the web version of processing. It's simple because it doesn't really have any commands, so any interactions or UI is just click and drag, but we actually need some instructions to be able to use it. There is some commands on the keyboard that you need to know because there's no familiar context to other apps except for click and drag. And similar to this project, I found a project by Devin Lul in Vega, which is really cool, but it wasn't until I looked for the source code that I found how to use it. It's intuitive, but not really, because it's making something easy or like frictionless, but you need to provide users with cues on how to use it, right? And the interactions and the commands that you have really determine what somebody can do and how they can do it. So what happens when we add intelligence to these interfaces, right? That's kind of the question. Like, we're trying to create intuitive interfaces or interfaces that make us arguably more creative. How do we do this when we have intelligence on the background? I like this quote from Cal Newport on Deep Work, in which he emphasizes that working well and creatively with intelligent machines will present a career advantage in our new economy. The good news is that a lot of people are working on making the use of AI easier, right? And I include myself. I'm going to show briefly suggestive drawing as a case study, which is my master's thesis at the Harvard Graduate School of Design, in which I explored machine learning and it's used to help humans and machines collaborate when drawing. Not necessarily when designing, but when drawing and sketching. We sketch, as I mentioned before, right? We sketch to represent how we understand the world. And even though there's software that makes our tedious tasks trivial, think of CAD or copy pasting or undoing, But machines don't really participate in how we interpret the world, as they cannot perceive it. But as we've seen, and as this workshop in which I'm presenting this lecture is working on, this is changing, right? We have algorithms like this one that is called SketchRNN that allows us to have a bird that is drawn by a neural network. This is a program that has seen 40,000 drawings made by humans of a bird, and it can generate birds from a few initial strokes or even from nothing. The funny thing is that no matter what we feed this program with, it'll try to draw a bird. So it's not going to draw anything else. It just has the narrow knowledge of how to draw a bird, or at least how to copy a human drawing a bird. So there's a boom on artificial intelligence and machine learning, and they can learn, for instance, how to continue a drawing, right? And, we have this concept of a machine with different inputs that force us to think in discrete units of actions with what I mentioned before, like clicks and command. And they tend to describe information with discrete and sparse representations. So for example, here we have what I showed before, a cat line that goes from A to B with 2 clicks. Thousands of people might do the same thing, but with a pencil, or like an Apple Pencil or some other stylus on a digital device, we could have the expressive medium of sketching by hand, and hundreds of lines might be different. This is good for AI because it's good at interpreting and generating fuzzy signals and approximating functions. So if you provide it with a really accurate input, you might get the same output for hundreds of people. This presents two paradigms of interaction. On the left, we have a maze in which we just want to solve a problem. We just want to get out of the maze, and we have a well-defined problem. And on the right, we have the non-deterministic way in which at every step that we change something, we have to reevaluate what we're doing. And this is more like what drawing is like, right? I built an iPad app for this project in which you could draw in collaboration with suggestive bots and other humans. You had on the left behavior, which is humans and bots, but no toolbar. And on the right, you had memory, which is a way to store and provide context of what and how something has been drawn, but no explicit layer structure. This is a project that tried to escape that point and click paradigm of deterministic machines that I mentioned before, with a continuous flow of interaction, where as another human could, if you're collaborating on a drawing or in a Figma board, bots can see and manipulate your drawings, and they may bring back a suggestion into the systems, right? I ideated and built bots with really specific capabilities, right? So each of them has a really specific task, let's say, and a narrow knowledge, and together could be combined as metabots, right? Here's the first working demo that I created. And one really good thing about this project is that I kind of stopped coding a month earlier, so a month before finishing the project, and started playing with the application and actually using it myself to see how it would transform the way that I was drawing and sketching before on the iPad. And another little detail is that I didn't really build the neural network, right? But the interaction system behind it. Let me see. Okay. So just to give a bit of credit, the neural network that is behind this project is called Pix2Pix. You probably all know about it by now. So this was a neural network that was released by Philippe Isola and his team in 2016, and then thanks to the port to TensorFlow of Christopher Hess, I was able to use it on my master's thesis project. And I'm now going to show individually what each of these bots could do, right? This is what I call texturer. It learns without a line of code, right? You already have Pix2Pix, and we just have to feed images to this algorithm in a certain way. The same way that you might feed images to StyleGAN or other algorithms out there. And the important concept to understand here is that we're generating, or the program is generating for us, new synthetic images. This means that these new images don't exist on the training set. The neural network, when we train it, tries to acquire or understand the language on the dataset images, and it finds a way to approximate new images that look like the dataset but that are not exactly on the dataset, right? I train, as you can see, models of flowers, abstract art, and dresses, and I think this is like I don't know why, but this is going really slow today. Okay, and probably even more. Yeah, I don't think you can see this right now. Okay, seems like it's going now. All right, so even more interesting, what I was mentioning is how this network works. And I think that even more interesting than using these models for something that is its original purpose, like drawing flowers if the model knows about flowers, is to use the accident to our benefit, to use it to something other than its original purpose. Because I think that there is something there where machine error might lead to inspiration, to unexpected things that we were not thinking that could be done, or we haven't really imagined that would be possible with the visual or aesthetic language that we were using before. Okay, another bot or like pigs-to-pigs model that I trained is called Sketcher. So it's trained on hand sketches of trees and urban scenes. I always give credit to the artist, which is my mom, that while I was training pigs-to-pigs models, hand sketched 64 trees from real life and scanned them for me, and then we formatted them in a specific way to make a data set and post-process their edges with Mathematica. What you can see on this slide is, let's see if we see it. Yeah, so these are trees that are going to be filled with, and yeah, sorry for the delay here. I think I'm just gonna stop recording locally. I don't know why this is so slow today. All right. Cool. This should go faster now, I think. Let's see. Yeah, a lot better. Okay, so I was mentioning these are hand sketch edges on the application that were requesting or were receiving suggestions of the pigs-to-pigs model that had been trained with trees. And what's fascinating is just with 64 trees that I'll show in a second, we can have a model that tries to approximate how it thinks or imagines that a tree should be filled with different forms, or even a building, as you saw there, how it can be filled with shapes that were not on the original data set, right? And for me, I think this presents a new way of collaborating with machines, because you can have unexpected collaborations in the system. And there's one thing that is really important that happened here, and it was due to technical challenges, is that the suggestions would come from 1 to 5 seconds delay, right? Since I had done the initial input sketch, and that made it feel that the suggestions were actually more human, because if you have another human, you need some time for them to look at the thing and actually have time to sketch or color your things. All right, so this is what a data set looks like. This is what we can find online. This is from the Met Museum, and we can generate it with some automation script. And this is the same from Flickr, where we just get images of flowers, and we can automate with massive amounts of data. But this is not how we sketch, right? We have here the data set of trees, which is more similar to how we would sketch. It's been done by hand, it's slower. And here the artist trains the machine by example. With a set of images, the neural network learns a new mapping. And this is the new paradigm in which we end up using really, really complex algorithms that are almost black boxes for us, because it's easier to train them. You just put folders on an image, use something that is kind of like a brute force algorithm to learn a mapping from input to output, and then we can create a new program. The continuator was another experiment that tries to learn a drawing sequence from trunk to branches and from branches to leaves. And this was something I thought it was not going to be working, but Pix2Pix managed to learn different mappings within the same model or the same dataset, right? So this means that we could have multiple types of input and output pairs inside of the same dataset, and it seems like it works. And then I was combining this with the Sketcher model. So this brings us back to that original paradigm that I mentioned before, that if you're playing with these programs, you may be doing that as well, of retraining the model and actually programming a new behavior just by providing it with images. The system, as I mentioned before, makes me draw differently as well. It proposes colors and textures that I wouldn't have maybe used, but because of the nature of how these programs are trained, they do. And this is the memory of the system, right? Which could serve to retrain new bots because it's encoded as PNGs with masks and also stored in a MongoDB in JSON format, where we have the timestamps and the coordinates of each of the strokes that have been done. And I think this will maybe allow us to build our intuition into how things work or not, right? There is the argument that because we see unexpected things, we might receive inputs, so outputs that we didn't know about. And there is also the thing that because the machine is filling in the colors for us, we're never going to be coloring, so we don't really practice the act of coloring a flower, for instance. And this is a more recent implementation of one of these models using Paper.js, Glitch, and Runway, which you're using in the workshop as well. You can visit the project and learn the entire sort of essay or visual essay at suggestivedrawing.com. And I'm going to show now another experiment that is ongoing research that I wish I had more time to spend on, but I don't. And this is an attempt to synthesize or hallucinate my own hand-drawn sketches. I publish sketches and stories, as I mentioned before, at sketch.no.ma every week. And I like to sketch live. This means from objects that I'm seeing as opposed to drawing from pictures that I've taken. And I've been sketching daily for almost 2 years now. I sketch at least one thing every day. And there are some of the drawings here that I've published already online. For me, this is a form of journaling. The format has somehow a stylistic consistency, and the challenge was to see whether the AI program, in this case StyleGAN, could replicate the style and generate new images. So I trained StyleGAN and generated drawings with the same style. And even though these images here look really similar to the style that I was showing before, they don't really resemble, right, when you zoom in. But these are, for me, I think, impressive results obtained with less than 100 drawings. And this is an animation and interpolation of the latent space of what the model has learned in StyleGAN. There's a selection, so I acted here as a curator. I selected by hand the drawings that look to me like buildings. And here's an interpolation of just those generated sketches of, quote unquote buildings. And here's another selection of drawings that look to me like paper bags or cardboard objects. They were all brown. And again, an interpolation of that selection. I think this is at least one algorithm that lets us make really interesting morphing algorithms from point A to point B. And there are some synthetic images zoomed in that I put here that I believe that if I printed in a gallery setting or something from afar, they would look exactly the same as my sketches. And it's crazy to see how the outlines, the shading, and the text labels are exactly on the right place as I could probably do by hand. So the next thing that I'm going to show really quickly, just this slide, is I trained a model of StyleGAN with 10 pencil portraits made by my mom, which ended up creating a dynamic portrait that morphs between different faces. One interesting thing is that even though there were 10 portraits, only the faces of 4 or 5 people are manifested here. And that talks a bit maybe about bias or about the curatorial aspect of what points in the latent space I chose later to generate this. But we can talk more about that later. As I mentioned before, I make the Getting Simple podcast. And I wanted to share with you the trailer of Sisyphus. It's a short film that I produced with Daniel Natoli and is available to watch at gettingsimple.com/Sisyphus. It's meant to portray the reality of our often repetitive lives, more often than not now, sitting on Zoom meetings like this one. And this was, this predates the COVID pandemic, so it's still current even before we had to wear masks. It played in Malaga and Seville's film festivals and is available on YouTube, and I'll just shut up and play it.
No, is there a sound to the video?
There is. You cannot hear it?
Yeah, I guess
you cannot hear the...
you just stopped the sharing just now, so maybe you have to reshare with sound, because I think you might miss clicking the share with sound option.
All right, let me try doing that. Make sure that we get sound and we confirm it. No worries. Share sound. Okay, so I'm sharing sound. Let me make a test really quickly here, because I might have to configure something that I didn't have configured. Let's see how I do this. Right. Cool. Okay, let me try again, and you tell me if I have sound now.
Okay, perfect. Yeah.
Okay, so we have sound. That's important, because we're going to need the sound in a second. Okay, so yeah, and just to show you some of the episodes in case you don't know, or the highlights that I will do if you're in this workshop or watching this talk on YouTube. Episode 3 is one of the first ones with Jose Luis back when he was working on his thesis with Máquina. Episode 25, in which Jose Luis interviews me, and episode 41, which is a recent catch-up episode where we talk about teaching, live streaming, publishing, and podcasting. Right, the one in the middle is kind of the origins of Getting Simple, so it talks a lot about why I do what I do and why I try to do all these things, and maybe I should listen to it more often to know why I do it. And here are some episodes related to interfaces and AI. So this is Ian Hughes, the father of Dynamo, Ben Fry, the co-creator of processing, and then we have Cristóbal Valenzuela, that is the main co-founder, I would say, of Runway ML, and Adam Menges, which is one of the co-founders of Lobe AI. I've also recently launched the new series called Bytes with Aziz Barbar, in which we're gonna treat concepts at the intersection of digital technology and culture in a language that we can hopefully all understand. We've released the intro, and we've already recorded an episode on Stalgan and another one on NFTs and digital art. And what we aim to do is to create or like generate conversation and also learn ourselves more of these topics. There is also a page on the podcast at gettingsimple.com/ask. You can send questions, and I'll be glad to answer them on the podcast as well. So I brought something. Let's see if it works. So we're going to be connecting to a special guest. So if you don't hear audio during the call, just let me know. And if you do, just let's go. And this special guest is going to comment on how AI and digital tools influence the work that we do as creatives.
When you think about using algorithms to help you and assist you in the editing process, you need a way of finding a metaphor or a tool that will allow you to collaborate with those algorithms. There's nothing in the interface that you see right now of video editing software that will help you do that in a way that's intuitive for you. We need those new interfaces, new metaphors and systems. And that's what we're building, basically. We're building those next generation of like systems to help people create video and create content. You don't care about the mathematical function that goes behind blurring or like doing a Gaussian kind of like effect. You just want the output of it. You want the creative output of like modifying and moving a slider or having an effect being applied to your video, your pixels or content. And so when we think about it from that perspective, we are building algorithms and models and allowing people to train new systems, but no, we're not focusing that much on like the architecture behind the scenes. We're focusing on the ability for you to like steer and control and have input on how you want to create an image and train an algorithm to generate the image that you want. More than like emphasizing too much the technical aspects of it. More than like adding new models to train, we're thinking about how do we add new features so people can control the outputs of what they're training on. And so I always come back to the analogy of the process of like you taking a picture with your iPhone. When you take that picture, no one is saying like, oh, the AI is biased or the AI worked or didn't work or it showed me like new creative possibilities. It just like works. It's a tool as any other tool. And so in general, I think all the art tools that we're making will eventually reach that point where you're not too concerned about the systems you're using and you're not emphasizing as much. You're just using it as a tool. And if it provides you with good results to explore a creative direction, you're going to use it again.
Okay, could you see that?
Yeah, that was great.
Okay, awesome. So as Cristobal said, I reached out. So he's like, as I said, the co-founder of Runway. Interfaces should focus on the results that creators make, not in the technicalities of how things work, right? For me, I'm guilty, as you can see here in this cloud of services and stuff, I'm guilty of getting too much into the weeds to learn how everything works technically. But that's, you know, the responsibility of us as creatives who know how to code to try to bring some meaning of how these tools are used or how they help us, right? And now I'm gonna go really fast, so to give you some pointers in case you don't know about them, some tools that I used to machine learn in 2021, hopefully pointers for you to get started or continue learning after the workshop. You know, a lot has evolved since Sketchpack, and if you want to get into or deep into AI and deep learning, I would recommend you this book by Aurélien Geron. The book uses Python, and that's the standard for machine learning development. You can use other languages as well, but for production, maybe you could use other programming languages like Java or Swift or C++ or things like this. So yeah, hands-on machine learning with scikit-learn, Keras, and TensorFlow. I have it always with me. It's kind of a book that I always flip through the pages and I keep learning new things. TensorFlow Core, TensorFlow JS, and TensorFlow Lite, different sorts of the same thing, but to deploy things locally on the cloud, on the web, and also on embedded devices. ML5, which is, you know, it's like the machine learning, it's kind of a wrapper around TensorFlow made by the people who make kind of P5 stuff and processing and things like this. Daniel Schiffman, also Cristobal Valenzuela, and many others. And, you know, here's a sample to classify an image on the web using MobileNet, an ML model, right? Google Colab, you've been using it already on the workshop. For those who don't know what it is, it's like Jupyter notebooks, but on the cloud, right? So here I'm doing math with Python, and I'm creating tensors in TensorFlow, and I'm visualizing them as images. So this is, it can be fun, right? Like I enjoy a lot these things because even for myself, unless I see things represented this way, I don't understand them, right? I see numbers and matrices and things like this, but it's not until I see some visual representations and a mental structure that it makes sense. Netron is a really cool app where you can drag and drop a machine learning model and inspect it and see the layers and what exporter was used and what version and things like this. And then we have Runway ML, which is you know, it's like what you're using on the workshop, and it's like this kind of Spotify for machine learning. It has a marketplace, and now it's bringing the SQL application to do professional video editing with AI. Lobe, in which you can right now train only image classifiers, but has a really simple drag and drop interface. You just drag a folder with subfolders per class, and then it trains. and Teachable Machine, that is similar, but it also tries to explain the technical concept. So this is for somebody who's trying to learn machine learning, not for somebody who just wants to use it. So wrapping up and coming back to things before, right? This is Teachable Machine, and now I'm going to also show conceptually or like diagrammatically how you would train Pix2Pix. So this is a data set of Pix2Pix. It has like each image has 2 images in the same one. So you have on the left you have the input, and the right the output. You can have the output on the right or on the left, it doesn't matter, but each individual image is 256 pixels, right? And if you have many of them, you make a data set, and then in something like Google Colab, you can train in a matter of minutes now, which is something that when I was doing my thesis, I had to wait for like between 6 and 10 hours per model, and now with this I think I can do it in 30 or 50 minutes or something. And training in Google Colab is good because you can get even the good GPUs for $10 a month and free GPUs for free, right? This is the architecture, so we're not going to get into this today, but at the end of the day, you just want what you have on the left is a generator. You give it an input and it produces an output, but during the learning process, you have a discriminator as well that is learning to detect which images are fake. It becomes better, the better the fake images look, and the generator gets better, the better the discriminator knows how to discern fake images from real ones. And, you know, I think you're going to see a talk with Charles Waldheim on Friday. I also did some work with them to prepare how to train StyleGAN models and help the Office for Urbanization at the Harvard USD train models and use them in Runway and in Colab. In this case, we use almost 5,000 images, which initially were landscape, and we had to train for 3,000 steps. So you can, you've probably seen this on the workshop. And this was the initial data set. So each image had to be converted, or at least this is what I did. I converted into square because padding, you are actually still training with 1024 by 1024 images, but you're like wasting training information with black fills, which you can resize back later the output if you want to keep the original ratio. And we end up with a training set like this one, right? So I'm not going to go into detail, but at the end you have like a model that has been trained on Runway. You actually get a latent spacewalk video as a sample of your model that you can save directly. You can generate others. And, this is something that probably Charles is going to talk more about, but these are some of the results that we got. And here's another interpolation video with the original aspect ratio, right? And this is something really cool. We've seen it now over and over. I think these things are, there is like a really fast pace that I cannot even keep up with, in which we see more and more things come up. And, as I mentioned before, I do the live stream and videos on YouTube. So there's a lot that I've done with Low, Runway ML, Colab, and things like this. And a lot of it, well, everything that is online is on YouTube. I do these live streams in which, and this is something that I would recommend anyone do. I go online and many times I just have like a loose idea of what I want to do. So I want to be improvising and learning as I record and not preparing everything in advance and then delivering that, right? There's like different reasons why you might want to do that, but for me it's because I want to get better at improvising and also feel a lot more comfortable when I have prepared slides like these ones, right? Like right now I have everything sort of scripted. I have a set of slides, I know the rhythm, I know what I want to say more or less. And if you do that practice then over and over and over, then you're going to feel more comfortable and you're going to be interiorizing your learning concepts a lot more. And I usually in these sessions I learn a lot of machine learning code and things like this, so this is the main reason why I do it, and also to share it with other people. I've been covering things like TensorFlow, AWS, Runway ML, Low AI, StyleGAN, Pix2Pix, the Suggestive Drawing Project, and many other things. And there's also some tutorials, talks, and conversations that I upload, some bits of the live streams. I also have some help to edit and upload as individual, like maybe 5 to 20 minute tutorials. And here are some of the samples, right? There was one live stream we did like object detection labeling and tried to train a model. DigitalOcean, which is learning how to deploy a website, web app, or even like run machine learning models on the cloud. StyleGAN, as I mentioned before, so I showed some of the experiments a bit more in detail. We also did some live training, Lobe AI and Runway ML, in which I also try these things myself. So I don't try these programs and then I do the live stream. Many times I try them live. So there's, you know, things that happen live that, as you saw today, that some things don't work as you expect, but it's good. That also shows how to fix problems to people who are watching. Teachable machine, as I mentioned before, we also take a look at how to train and generate data sets for this. And you're all more than welcome to the Discord community. You can connect with me and other minds alike. George, for example, organizing this workshop is online there. And you can go to the invite at None of the Maslas Discord. And yeah, so thanks a lot for your time and attention. I really hope you enjoyed it, and I'll be happy to discuss any questions you may have now.
Thanks so much, Nono. That was a really inspiring lecture and always great to see your work. I do invite the members, the participants here to turn your cameras on if you're comfortable, and I do unmute yourself and ask any questions. And those on YouTube, feel free to write in any questions and I'm happy to read them out. Maybe just as an icebreaker, and hopefully we can get some questions in from participants. It's really inspiring to see these processes. You focus a lot on these processes of simplification of the design process, you know, starting at almost the primitive sides of the sketch or semantic approaches, and using machine learning without actually coding. These processes really democratize the design process. So I'm curious to ask you maybe a first question relating to the role of the designer, and in this case, the role of the architect. How do you think that will evolve? How do you think the creative process using these tools will evolve in the future? Thanks.
Yeah, so what's really, let me just switch something here and get some water. So what's really interesting about what you said, I, as a prompt to this talk and some other talks that I want to give on the same topic over the next month, I reached out to Cristobal and we actually had a conversation on this very same topic. So I asked him about, what do you think the experience or the discipline of like design, art, and architecture, how is it going to change over the next years with AI and machine learning, right? We're, you know, as a spoiler alert, I'm releasing the episode, it's like a really short 20-minute episode tomorrow. I think he has been like working with these concepts over many years now, and is solely focusing on how creators are going to use these tools. And he's already seen that this has happened on the VFX industry, right? Like video editing and like people creating tutorials and not tutorials, video clips and other resources, right? And what he mentioned is that we're going to see that the important part on how our work is going to change is going to be on not the techniques or like the models, as I mentioned before, but on the interfaces and how we let people use them, embedding those processes inside of your current workflows, right? I would imagine that we're not going to see, I don't know, I think one thing that I like from what we've seen today is like the example he puts with the iPhone, right? That you don't really care that the machine learning model is enhancing your photo or something, but that the result you get at the end is good. So I think what we're going to get to is that there are going to be so many like little machine learning optimizations on the same softwares that we're using nowadays, but we're not going to even know that they're using AI, right? I think that that's going to be the first step, which is really little optimizations and things that are going to happen that are going to make your workflow faster, or maybe automate, or maybe remove the tedious parts of the kind of the cat monkey world. And maybe later, as a like a parallel branch, what we're going to see is that there will be hopefully interfaces that are like a break from what we've been using before, and that radically changed the paradigm. And this is what's happening, I believe, with Descript, for example. We talk about that with Cristobal on the podcast as well. Is a startup that created a tool to edit podcasts with AI. So you drag a file, a video or an audio file, it automatically transcribes your entire file, and then you can edit a piece of audio and move parts around as if you were editing a paragraph of text, right? So this is something that will be really hard to change the entire workflow, maybe on Adobe Audition, to edit audio and do it this way. But because they started from scratch and they just envision how does it look in 2020 or 2018 to edit podcasts with AI, right? And I think that, those little bets of say, let's create a completely separate program instead of just creating a plugin for a program is what we're going to also see. And hopefully we see, I think we're already seeing that in architecture as well. But yeah, I think that's an answer to the question. Hopefully that is in line to what you were thinking. Do you guys have, just curious, do you guys have the link to the live stream? Because the one I had is not really there. I'm not sure if this is...
Right. There was a slight change with this. Apologies for that.
Okay.
Do we have
I just want to see
from the participants?
Hello. Yes. First of all, thanks Nono so much for this amazing presentation. And I would build up on George's question in terms of architecture or in terms of building as a product. So including the whole life cycle or including the whole processes of the building. In your opinion, how these new technologies in terms of machine learning, in terms of different types of machine learning, how it would affect the process in itself? Because as you know, in any introduction, in any paper, in any presentation, we always see the first 3 slides of the problem of CO2 emissions, the problem of construction affecting the globe. So in your opinion, taking the whole perspective of architecture, of construction of our ASC industry, how do you think these tools would help evolve or solve, more or less, try to solve the situation that we're facing now? Thank you.
Yeah, first of all, I think that's a really good question. The problem is that's not my area of expertise. So I'm as curious as you are, I believe. I think on the side of CO2 emissions and energy and all these things, I'm actually not. You probably know more than me about that, I would say. But I do think what I'm looking forward is for like the interaction paradigm to evolve a bit. I don't think we're gonna, as I mentioned, I don't think we're gonna see that at the beginning more than optimization of processes. And I think the first thing to the user that's gonna happen maybe is that you're gonna get things done faster and maybe cheaper. But I cannot answer that question. I'm not looking or like researching in that field. So that's, yeah. Other than what you can see already, that many people, and I think what many people would defend here is that problem that you mentioned is not only affected by AI and machine learning, but by the entire paradigm of user interaction and programming, right? Like there is still opportunity, and I think the folks, for example, at Hyper are doing that. There is a lot of opportunity on like rethinking how buildings are made with code, for example, right? Like coding, like we were doing things in Rhino now, but are there better ways to do that just with code, even without machine learning? And so we have the possibility to rethink the workflow in many aspects, not only involving AI. I would invite anyone, if you guys want to also chip in to answer to Ahmed, and maybe if you have any thoughts.
Thanks, Nono. Anyways, still, from what you get from in my opinion, once you have the concept or once you have the workflow, the idea of you bringing the nothing, or like the final product that you made is really amazing. So I mean, to take this workflow and try to somehow, let's say, link the different discrete parts of construction, I think somehow it gives inspiration too. So thank you anyways. Thank you.
Yeah, thanks for your comment. I think, what I'm surprised is that there's so many papers and so many new algorithms and like NVIDIA and like Stanford and all these things, but we're not still seeing the effects of all of this stuff, or at least not so much on user interactions, right? I think one of the leading kind of bodies here, I would venture to say, is Apple. So for example, in iOS 15, they're introducing image to text transcription and things like. They're trying to smoothly incorporate AI into their operative system. And if you take a look closely at what they're doing, they're actually trying to make it so every single feature looks really familiar to the user, and they don't even know that it's AI, right? They only mention AI for like tech savvy people or like other people, but for the common user, they say, if you take a picture, you're going to be able to select and copy text from a photo. They don't say, excuse me. So they don't say you're going to be passing your image through machine learning, and then you're going to be able to get an output of the text that is on the image and the coordinates, right, of each letter. So that, I think that abstraction layer is what we need in the industry, where things are embedded smoothly.
Do we have any other questions from participants?
Well, what I'll do also for the thing here, I don't know if you guys have, I'll put the link here. I'm trying this format where you guys can send from your computer or phone a voice note to me, so at gettingsimple.com/ask, and I'll put it also on the YouTube channel. And if you have any further questions about this, about the podcast topics, about the kind of suggestive drawing work and stuff, feel free to send them my way. I kind of, as a notice of what just happened with the question that Ahmed asked me, my work focused mainly on machine collaboration with humans in the realm of drawing and sketching. I was trying to kind of get a bit outside of the design aspect of architecture and go more into the artistic or like inspirational side that the freehand sketching medium has. Whether that can be, those concepts can be incorporated later into a more formal architectural design environment, that's up for like debate. It's not directly translational, but I think there might be some things that can directly transfer to the art discipline.
I have one more question, if I may. Well, thank you, Nono. It was a great lecture. I appreciate your work in sketching and how it actually combines with AI. I think it's a very soothing medium to combine with AI. And I prepared a little question here. Just as it has been happening with the post-digital drawing and the post-digital rendering in the past couple of years, these sort of painterly condition that the style gun and the pix-to-pix models have, how do you think will affect representation in architecture in the next years, or the production of architecture, or your work in sketching or in architecture?
Yeah, thanks. So this is similar, I would say. It's a bit slightly similar to when you have Shutterstock or like other platforms that let you get illustrations, or like I think it's Fiverr or Fiverr, where you can pay other people to do illustrations for you, right? So you're like delegating the work or like buying the work of somebody else. I'm a bit worried about the need for illustrators and are like people who actually sketch by hand and do these things as a job. I've never done this as a job. For example, I did it as a hobby. There are many tasks that we still did manually, or we still do manually, like filling in the texture of a tree as I showed, or like buildings or things like this. So there is an opportunity to translate that into the actual production realm, like auto-filling textures or auto-filling things for quick sketches, right? And I think it will streamline the process of you going from a sketch to something that you can see is textured and maybe can let you imagine the project or the thing that you're designing on the art piece that you're making better in like with a faster iteration loop, right? So you can imagine, for example, if you build a 3D model, you've built a 3D model because you want to now take views from it and see the project from different perspectives. So you do that work because then you're going to be able to imagine the spatial qualities of what you're designing better. So here you could say, okay, I want to make a sketch, but then I want to color it because maybe I can imagine or I can communicate to others how these textures and colors represent the space. So if we can now streamline that part, maybe we can skip that process of actually coloring something or having to do the manual work that we already know how it is, right? But we just have to do it, like coloring or like doing other things like creating a 3D model. So there is like a not that you're going to skip that work, is that you're going to be able to modify the input iteratively many times and automatically see the output updated. So it's going to be part of your creative process and your loop in which you go back and forth between concept and realized idea. I think the main change there is that iteration loop allows you to try many different things, whereas if you have to build a 3D model that is really detailed, you're going to have to build it once or twice depending on your time constraints. But if you can build many because you can iterate faster, then that presents an advantage and probably benefits the design outcomes that you're going to make or art pieces or sketches. Well, and thanks a lot for the question. So just one comment before I go, because I'm gonna have to drop off. Because only Ahmed and Carlos talked. I just would like to know. It doesn't need to be. It can be now, or it can be later, or it can be a private message. If I could use any of your audios on the podcast in case that I publish anything related to this. If not, it's also fine.
Yeah, sure.
Yeah, and so George, I'll let you go and let you continue with the workshop.
Thanks so much, Nono. It's great to have you here, and have a great day.
I would just post for I don't know where this goes, but I'll just post the invite to the Discord server. If you guys want to, I would be really happy to see some of the outputs that you do design on this workshop, or the models you train, or things like that. And also invite you to see some of the live stream videos, because there's a lot of content on Lobe AI and Runway ML. And I think also the content that you're producing, I took a look at the video that you did yesterday. I'm looking forward to watching as well. So really recommend it. And thanks guys for putting this together and inviting me.
Thanks again, Nono. And if you're free again, do join us on Friday for the student presentation.
Okay, I'll try. I'll do my best. Thanks everyone again. Thanks for being there, and I'll see you next time. Bye.
Bye. All right, so I think we can move on to the next step. I hope everyone enjoyed that. I will ask again, I know this is live streamed. If everyone can put their webcams on, that would be great. It makes teaching, I'm sure Dong-Young will be happy to see some faces or reactions or whatnot while we talk. So I'll leave the word to Dong-Young, and excited for this implementation.
Yeah, good morning, good afternoon, good evening. Yeah, let me just share my screen first. Yeah, can you see my screen?
Yeah, we can.
Yeah, cool. So I'm gonna be tutorial instructor today. And then let me just turn on the slideshow. So we are in day 2, and actually I'm divided like my part into 2 different topic. The first one is more about the image, the manipulation topic. And then the second part's gonna be the manipulation of the latent work. So I'm just going through the tutorials and have the Q&A session, and then jump on the part 2, and then I will explain the basic background of like GAN, and then we'll continue to teach you like how to extract the latent images, and then how could we play with those images. So I'm not sure how you if you like it, but this is kind of the basic workflow from the methodologies. So let's jump on the image, the manipulation part first. So it's gonna be more the tutorial based day, so just keep tight. Okay. So I think you already got the file links. So I'm start with the image tutorial 1, the grasshopper file first. Yeah. So yeah, it is better just you can open the file first, and then just let me know if there is the missing library or the errors. Yeah. So let's start with the image, the translation first. So the basic idea is to let you know like how to import the images from the local drive and the certain paths, and then like go through the filtering process. I think you are already familiar with like the filtering process. Like it is very similar to what you have done in Photoshop, like the screening or overlay or the darkenings, that kinds of stuff. And then also, I also will introduce some of the different features like the threshold or brightness or saturation. So it could be used for the image, the translation. So you don't need to like directly use the final output. I just wanted to give you the chances to manipulate the output for the taste. And then also there's the convolution or features. And then also in the last stage, I just want to show the advanced like workflow. So let me just go through it first. So basically I couldn't introduce all like the component just step by step. So I just go through from like very basic, like big chunk of the part, and then, oh wait. Yeah, let's go. So I just importing like the landscape images, and then yeah, and then here's the images I imported, and I just translate from the image file into the mesh. So that's why you can see the image files. Okay, so I just want to show some of the quick note. So if you zoom down, it's like all the mesh surface. So it's very hard to see the actual the image output. So there are actually mainly 2 ways to see the output. The first one is like use the render view. Oh no. No. Just use like this the preview, turn off the preview mesh edges setting in the display tab. So you can see here, you could see this very clear. the images, and let me jump on the next step. So I just import some of the city plans, and what I want to do in this step is to resize the images. So I just use the resize the component here. You can find this component in the NJS library. So yeah, so actually I uses manually the pre-made the tutorial that already NJ made in the Food for Rhino. So if you are more interested in like this stuff, you can also find all the information in the Food for Rhino, the numeric image utility, the plugin. It's all already in the Grasshopper file. So, and then just using like the component, you can like directly change the size of images. And then what I want to do in this script is that I just imported some the points and then wanted to find the closest point from the input. I think you can see the translation. And then from this point, I want to get the color of this point. And then after extracting the closest point's color, I just directly connect to the Python component and then create some the threshold that is more about like, so let me just, so as you know, there's some the RGB value. So what this component doing is that we have like 30 and 50 and 0 value. And depending on this, the tolerance, we calculate the threshold in between all the pixels. And we just loop through all these the points, the color of all the points, and then just filter the points color that are in between this color range. Yeah, let me, yeah, clear. Oh, yeah. So this is the output points that have some of the similar color. I can define it as some of the similar color. So when I adjusting the slider, you can see like this the filtering points. Yeah, I think you can have access all these files in the Dropbox link. Yeah, so actually we will use this algorithm as some of the main algorithm for the final step. So keep in mind. And the third one, it's just more the simple. So I just import some a doc image, and then let me turn off the mesh edges. And then yeah, dogs and cats, but it has some the different size. So I just extract some the one of the image size and then resize the other image to make sure they are the same size to filter both images. And then after that, here's some the filter you can use. So actually there are some diverse the filter. So in here, we just stack these two images, and then we could do some the different filtering. So just you can do some the multiply and lighten or some the screen. Yeah. And yeah, soft light, overlay. And also you can set some the different value. So this is like the pipeline that you allow you to just manipulate or some the input images. So I think you can use the style again output as an input, and then just move some make some your own the workflow to manipulate the images for your intention. Yeah, and then also I imported the cat image, and there's some the stuff like you can like change some the threshold. And then you can like set some the basic the high and or the low value. All these come. Yeah, actually, is it from here? So, yeah. So, I think isn't that pretty meaningful? Just go through like all the components step by step. So I just like go through like simply all the components. So this is the threshold, and then is it the same? So this is like some the brightness component. So the left image shows the left image is an original image, and then the right one is the manipulated. So if I like, wait, this one, not this one, yeah. So I can like control the blindness and some the contrast. Yeah, actually it's pretty fun. And also you can do some different the hue and saturation, the stuff like similar to what you have done in Photoshop. Saturation and different lightness. And also there is the convolutional filter. What is that? So I think I don't need to like go through like what exactly this filter means. Just there's some the mathematical the principle that allow you to get some the intentional the output out of this the convolutional convolutional corners. So just you can like play with this some different the inputs, like you can make some the blurry image and sharpen, or you can do some edge detection. Oh, yeah. So as you can see here, when you change this corner, it automatically assigns some the specific number to the convolution filter, and it will do some the filtering into all the images, and then you will create some the result mesh. Cool. And then this is some kinds of the intermediate part. Yeah. So I just import the images and then just resize the input, and then do some the convolutional filter. So in this case, I do some the blur. So the output is gonna be more blur, but I think it's already too blurred. So let me just do some sharpen. Yeah, it changed. And then wait. Yeah, and then I also did some the similar stuff, like put some the input points here, and then find the closest points, and then extract the points color, and then do some the filtering from this the threshold. So the output gonna be like this. And you can also change the direction. So this is like in a bit like some the brownery color here. But if I move this the points to like more the white side, like this, the component are more trying to do get some the. I think it's not actually the white, yeah, but I think you can see some the different patterns, yeah. So if I like select some the very dark black the color as a reference, you might can get very only dark the points pixel in here. Okay. And also I wanted to introduce import all the images in your local the directory. So what you need to do is just write make sure you write the right path in your the image directory, and then the Python component just automatically loops through all the file in your the local directory, but it only filters only the image, the extension, for example, JPEG or PNG, that kinds of stuff. So, and then this component just shows or, so you can directly select the specific, outputs from these images. And then you can also do some the resize. And then this is the imported image. So this gonna be like the the bottom, the elevation of the Rukurubijas, the Velocibra. And then this, I think this is the top. So what I wanna try to do here is to do some the blending filter. So like multiply, some overlay. Yeah, it's pretty interesting. And then also you can try to do some the convolutional filter. Yeah, I just use the resize one. Just let me reconnect. So this is normal and some the make it sharp or some edge detection. Yeah. So what I wanted to give you in this tutorial is that you don't need to do some the Photoshop stuff like continuously. Just you can do directly import your image into Grasshopper and then just do some the image manipulation in here, and after that you can directly use the output after the image the processing. So this is the first one. And then let's jump on the box, the tutorial first. And then I open the Grasshopper file, the box workflow. Number 1, import image. So, okay. So do you guys are all good or have any like questions and like comments or?
Feel free to unmute yourself. It's a good time to, if ever anyone's having any problems.
Only one question.
Yeah.
This script, all of these are for one single image? Are they for one single image or multiple?
Yeah, actually it depends on the input. So you can just, so if you import the multiple images, it's gonna like loop through all the images at the same time. So it's like just depends on like if you use it at a single the item, it just give you some the single output. But if you use it as some the list type of the input, it will gonna be some the list of the images. Yeah.
Okay.
Okay, it seems like I'm doing very well. No one ever like any questions now.
Is everyone on following? Okay. All right.
Yes.
Take
Yes.
that as a yes. Thanks, Ahmed. Thanks.
Yeah. So it's like some similar the process. So I just make some the put some my the file path and then loop through over my the directory and then just choose one of my the images in that local directory and then resize them. So I'm got some the elevation of the Villa Savoia here, and I just got some the cat picture in here, and then you can do this the image the manipulation directly. After that, what I want to try to do is that I just want to place this image in the right direction. So actually, this is the top view, but actually this is the front image of this the building. So I just wanted to orient this image in the right direction. So I just do some this the orient component and then just rotate it just to make sure it is in the right direction. And what I wanted to do here is that I just want to loop through all the vertices, the mesh vertices color, and then decide one of the channel, either the red or green or blue, and then normalize them from ranging from the 0 to 1, this is the value, and multiply some of the factors. So what this the component doing is that it gives some the vertices based on this the factors. No, wait. I think this is more the intuitive. So, and then I just make some the array of the points out of this the component. So there's some the empty the places where the pixels on, and then I just select the most outer points in this the array. So this is what I wanted to get from this the filter. So what this component doing is that it filters this the output that is the darker color extracted less. So for example, this window shows better the darker color, and then it's just extruded very little, but this the old white the background extracted better the large distance. And then also you can play with some the different color channel, can change the green or the blue, but I think it doesn't like change a lot because this image is already like very the gray images, so the RGB color is in almost the same the range. And then also, and this is the direction of the extrusion. So I already set this plane as the X. So if you select some the different the Y or Z, it's gonna like make some the distorted the output. So I would rather recommend you to do some use it only X or minus X. So it depends on the direct. So it means just the direction of the it means just the direction where this points the extruded, like the positive direction or the negative direction. Okay. And this is some different stuff. So I just decide the cat and just reorient it. So I think you can see more the different effect in here. So when I like choose this red, but if I like choose green, red, yeah, actually it's like quite diverse. But if I choose a landscape, yeah, see here. If I choose the blue, it already filters most of the blue, so it extracted like a lot. But what about like this, the greenery, the places? Or if I choose green, like this, it seems like this as you know, the white means the 255, all the RGB pixels. So white has a higher value of all the different channels. So it always gives you like higher the value in this the filtering process. But yeah, it's pretty like interesting. So using like this component, you can extract some the specific color, the channel out of your the images, and then extrude them based on these the factors. Okay. Any question? Can I jump on the next stage? You don't see any picture points. Or you import the right image? You have to make sure you write your own local directory in this file path.
Yeah, I have. Can you hear me clearly?
Yeah.
Or
Yeah.
Okay, so I have created a folder for this grasshopper, and I have also put some photos in that folder, and I have copied the file path from that folder, if that makes sense.
Yeah.
And I have selected the photos from the folder in item selector, and still I don't have anything. Maybe I can share my screen if it's okay for everyone and you. Okay. Can you see my desktop now? Yeah. Okay, so I have made two folders, one and test 2, and in those folders I have some pictures. And in Rhino, I have copied the file paths.
I think the result is too small. So just could you go to the right, the mesh component?
Okay, sorry.
Just click any the points. Yeah. Like and just could you select any component?
Yeah.
Yeah, and then just press wheel button.
I don't have the wheel button. I'm on touchpad. Yeah, if that makes sense.
I think you can zoom in.
Okay.
You're the Rhino environment.
Oh, into that point, yeah, it looks empty, or I couldn't see it. Oh, okay.
Right.
Okay, sorry. Yeah, sorry about that.
No.
Thank you.
No.
I'm so sorry. Yeah, sorry.
Okay, good point. So the reason why I ask you to click the wheel button is that when you select the component and click wheel, there is the function called the zoom. So if I like zoom very like out, but if I wanted to go there, just click the wheel button and then just zoom. So it gives you some the direct zooming.
Yeah, I should get a mouse with a wheel. Yeah.
Yeah.
Thank you.
Yeah, I think there is some I'm not sure it's gonna work, but yeah, cool. So seems I can jump on the next. Let me turn the chat. Okay. So here, I also import some the images and then do the same stuff, just orient in the right direction and got the output. But what I want to try to do here is that I wanted to make some the 3D geometry out of the points. So what I used in here is like some the plugin, the sample voxel, and build iso surface, and some the smoothing. So you can directly plug in all the points you wanted to create the mesh, and then just decide the voxel size and then effect range. Wait, I think this is too small. Huh. Yeah, actually it's weird. Actually, generally it doesn't show like this, the red one, but it's later. Weird. So what this guy is trying to do, wait. I think it doesn't filter all the points. Oh. Yes. Okay, little weird. But what I want to try to do is, this component allow you to create the voxel from each the points. So the value gonna be the voxel size, and then it will search from the neighboring the points within this range. So the higher range requires more time to calculate the mesh generating process. And then after creating like the several voxelized mesh, this component allow to like combine all these meshes into just one single mesh. And then you can also do some the sampling. And then the final smoothing component also allow you to smooth your mesh. So the higher value means the more the smooth the value. But I just recommend you to use like 2 or 3 or like just less value, just to make sure your mesh gonna be your mesh preserve the original input out of the several points. So this is actually, just let me change my yeah. Oh, yeah. There's some the error, I think. Yeah. So I just uses the city plan, and then extract the points, and then create the voxel size 1 and range 5. So there's some the description here. Yeah, the target mesh face size, like which means the voxel size. So the smaller value means the higher the resolution, which means it requires more the computational time. And combine them and smooth them. And this is your result. So this methodology allows you to get some the 3D geometry, 3D mesh out of your the input images. And I just wanted to show some simple the draft angle display. Just you can just choose some the minimum and the maximum the range, and then it directly give you some this the draft angle visualization. Cool. Is it all good for you guys? Any questions? So the main point is to extract this the array of the points out of your the single images, depending on the which the color channel you decide and your the factors. Cool. All good? If good, let me just jump on the third one. Okay. So what I want to try to do in this stage is to place all the elevation images in the right the position. So is it just the multiply some the iterate the step I already have done? So I just import this the front, right, and bottom, and like these all 6 images, and then import it, and then resize them. So here is the 6 images. Actually, this is the overlap. So let me just show you. So one by one. So this is the top images. And then this is the right. This is bottom. And this is back. Yeah. And then I just do the place them on the right place like this. And do all the same stuff. Oh. And here's the outer, the layer of the elevation, the front elevation, I believe. Yeah. And here is the, so depending on your the factor, you can decide the gap between these the points. Oh, sorry. Oh, oops. Sorry, guys. I just actually the next step is to create the meshes out of all these the 6 the elevations points. So it requires more time to calculate it. So I just combine all these meshes. So I'm not sure you can see some the inner the empty space in here. But let me just give you some, oh no, this one. So can you see this the empty space inside of this the box? So it's very like similar the concept, like how the architect make the 3D geometry out of the elevations. So I think if you have some the architecture background, you already learn these kinds of the methodology in your like undergrad, like in your the first, I believe in your the first year is very like basic the principle of the how to translate your the 2D images into the 3D form. but I just do this stuff in some the computational way. So also you can like change all this stuff, but as you can see here, this component require like about like half a minute. So I don't want to try to just change some of the input, but you can like try it, or you can just try to change the values in more the smaller the size of the box cells. It could help you reduce your the computational time. And then here's some of the mesh output. But in this process, I feel like the more important thing is to get the inside the foam rather than getting the outside of the mesh. So the next process will introduce you to get the inner the meshes. Does it sound good? So in this process, we orient all the images in the right place, and then extract some the point channel colors, and then just move it that from some the factors, and then just create some the mesh out of the points. So the basic idea is that I just wanted you to play with the algorithm, but rather than use it direct the 6 elevations, rather you could use some your own the geometry. So actually you don't need to use all the 6 elevations. Rather you could use only like 4 the elevations and make some the kinds of the pyramid shape, and then extrude some the extrude all the points, and then got some the overlapping points, and then just create some your the own meshes. So what I wanted to point out in this stage is that you don't limit it to yourself into some the box like the shape. I just wanted to open some the gate, like you could play with some the different the coordinate system that you define yourself. Okay, sounds good. So here's the last one. So let me turn on the stuff. So this is the final results from the previous stage. And then what I wanted to do here is that I just wanted to create the array of the full the points box grid, and then just carve out some of the points that are already used. I mean, I just wanted to check whether some points are inside of that mesh I already generate or not. So based on the 2 different points, I can carve either the inside points or outside points of the previous mesh. So this is what the component doing. So I just create the array of the 3D box grid, and then just find some of the mesh inclusion. And then here's 2 points. So this is the points are outside the mesh, this mesh, and these points is inside the previous mesh. So I just wanted to use this mesh for the next step. And then what I wanted to do here is that I created the mesh from the previous points, these points, but I wanted to use some of the color information from the original input images, because it's very like tricky to use the material, the texture in the mesh. So rather than just texturize it, I just wanted to use the original one. I think that's more makes sense for me actually. So I just calculate the closest points and then extract the color and then remap it from the meshes. So this is the final output of the process. So let me. So as you can see here, in my mesh, it preserved all the original image's color in the right place, and then extrude it in some certain range based on the factors. Cool. And then, yeah, this is kind of the modeling process. And then I just want to show some the visualization stuff. So I just imported the curves here. And then when you click, so I'm gonna create the clipping plane from the curve, and then want you to manipulate the clipping plane. So if I hit the button, it creates the clipping plane. And then if you wanted to flip the direction, you can just do like that. And then just hit. Wait. Actually, when you hit the button, it will generate the clipping plane in Rhino. So if you change the clipping plane, you need to delete the previous clipping plane and then just hit this one. And then the slider allow you to manipulate this process. So let me maintain the previous one. Yeah. Cool. So it's all about the part 1 session. So do you guys have any question or some opinion or some curiosity about this workflow? Just please unmute yourself and then just shout it out. Everyone is good so far? Okay.
So my only question is, so the expected outcome is this type of cuboid form, right? It will have 6 faces, something like that.
Yeah, kind of. But actually, it strongly depends on the intention. So I just wanted to use the traditional methodology that already the traditional architect have been used. So
Sure.
So you don't exactly need to follow the 6 cubic projection. Rather, I strongly recommend you to explore the new kinds of the coordinate system you're on. And then it need to be aligned with the concept, like what you wanted to explicitly say something, or what I wanted to show out of this process. Cool. Any other questions? I think if you guys don't have like any questions, we could have some the short break time. So let's have some the break in 10 minutes. So let's.
I actually had a
Yeah,
question.
yeah. Go ahead.
I got stuck in one of the scripts earlier. Was using,
Sorry, could you speak it loudly?
hello, can you hear me?
Yeah.
Yeah, I got stuck in one of the scripts earlier. So I just share my screen like that. Just speaking and then
Arya, I think you need to come a little closer to the mic.
Yeah.
hear me now. Is this better?
It's still a bit faint, actually.
Better?
Mm,
Okay, actually, I'll come back. I'll just.
now it is better. Now it is better.
Oh, all right. I actually got stuck in one of the scripts earlier. So I'll just. Yeah. So out here in the second script, if you can see.
Yeah. So actually, it strongly depends on the geometry. So if there is some the error message, there's some fucked up. So you need to change some the parameters. So I strongly suggest you to change some the effective range first. So I think you could put some like range 4 or getting bigger. Yeah. So as you can see here, right side and left side, you can see some the cubes appear.
Yeah. Okay.
Yeah. So it strongly depends on the input parameters. So just try to change the input parameters.
Okay.
Sometimes changing the voxel size will help you. So actually, it strongly depends on the geometry. So we couldn't set up some the concrete or very the general the input size for this the component. So just read this the side note what I have read and then just find some the sense of like how to play with this the component. Yeah. Any other questions do you guys have? So if not, we could come back to 11:15 and then I will go through the part 2 session. So I will just keep in here. So just guys just grab some the coffee or some goes to the restroom and then just shout out if you have like any questions or something. Okay, so let's see in 7 minutes, 11:15. Okay. Let me share my screen here. So part 2. So let's switch the gear a little bit from the image-based manipulation to some the latent work. So I'm just wanna go through the background of the GAN first, and then just give you some the tutorial, like how to get the latent work video from the Rune and extract the images, or like vice versa. And then I will also show how to connect the Grasshopper to Rune in a more the advanced way, and then we cast some the output directly from the Grasshopper. And last but not least, I'm just want to show to the second, the latent work stacking, the methodology. So let's start with the background. So how a human classifies something. So how can I define myself? So I think I could be described as students and my height, my weight, and where I am living, and my hair color. And there are like tons of the categories I could describe. And then you can also be described in the same sense, right? So we could specify all lots of the variables. But how computer define something? So let's say we wanted to define some the human face. So computer only know the numeric value. So it could be like the size of the eyes, or the skin tone level, or hair color. So it could be described as some array of the lots of the numbers. And then we are gonna say it as the vector, the n-dimensional vector. But like it's spelled like conceptual way. So the one by one transition is more about like the human cells, and like they could recognize the size of the eye or the skin of tone, but they could capture some the abstract feature of the human faces in some the numeric way. But there is some the loss of the scale in the different features. So how computer could capture in some the different scales? For example, some in the faces, how could capture some the acne, or some the eye shape, or some the hair color, or the face shape? So the convolutionary the filters appears to solve these problems. So the most left layers can capture very like small scale, and then it goes the right size. It could increase the size of the range they can explore. So the 1 pixel could represent the one size of the acne pixel, but in the second layer, the first one can capture the 9 pixels, and then save it as the numeric value, and then it goes like to the right size. Just a single pixel can explain the loss of the pixel just as a single the numeric value. So actually this is like quite the conceptual way. So I just wanted to give you like some very like, I don't want to give you just a very technological the background. Rather, I just wanted to give you more the conceptual way and how the architect could understand it and how could we use it. So this is more similar to the structure of the autoencoder, but I just wanted to use it as the abstract way to help you understand how the GAN works. So the input images, so you can put some of the input images here, and like the convolutional neural network can capture the smaller the features in this layer, but it's getting bigger when it goes to like this layer. So in this level, there is the vector created. So in the DC GAN, there's like 100 dimensional vectors, and in StyleGAN, there's like 12 dimensional vectors. So by training the GAN model, the GAN model will create the latent space that is filled with the numeral vectors. So what they can do later is that they can get the input vector from the user and recreate images based on what have they learned from the inputs. So which means the StyleGAN has more the dimension vectors than the DCGAN. So it can capture more the subtle features from the training set. But the vector is defined as the numeric value. So this is very like interesting stuff like came up. So if the long hair defined as like this vector, and short hair could be defined as like this vector, we couldn't exactly know like what this specific the number means, but we could do some the math to find some in between these two vectors. So I just find some exactly the intermediate the vector, and could we say it is the intermediate the length hair vector? So this is kind of how this latent work. So if we find the smiling woman, and there's the neutral woman, and there's the neutral the man, we could do the math like to erase the woman and adding the smile faces. So the output gonna be like these images. Or we just do the math to subtract the man and adding woman, and they don't have the glasses, but this man has the glasses. So we could do some kinds of the feature the matrix from the latent vectors. So the output image is gonna be like woman with glasses. So in short, if we know the two vector images, we could get the numerous intermediate vector using some mathematics, and is it called the latent walk. So this is why we introduce you guys the runway ML, because it is like very intuitive the platform that allow you to see the actual the output rather than the numeric the latent vector. So depending on what the images you choose, you could generate the intermediate the images based on your whatever you choose. So I just want to show you like how this guys works. So I just import the Coral GAN. So when I wait, so it requires the vector value. But the main advantages of using like this runway platform is that based on this vector, you could see this wait, regenerate query. Yeah. You can see like lots of some diverse these images directly, and then just click it, and you can see like different the result here. And at the same time, but so you don't need to like worried about like how to deal with this each vectors. It will handle all the stuff in a backend. Cool. So this is just the basic explanation of the latent work. And I just want to go through like how can we connect to the runway ML in a more the advanced level. Okay. So in this, the first days, as I said before, the style can take 512 the input vectors. So what I have do in here is that like creating some of the random vectors for the input. So I created this 8 images first, and then wanted to get some of the 20 intermediate vectors. So the output gonna be like 20 multiply 7, which means 140 the vectors that have each of the vector will have 512 dimension. So the vector range gonna be like -1 to 1. And then just create some stuff. And outputs gonna be these the random the vectors having like 512. Oh, yeah, 512 vectors. And then and then use it some the pre-made the runway component, and then do some the job, and just host local host. And then what you need to do is just turn true. Oh, wait. I need to run it remotely first. So make sure you running this model first. Okay, it's mounted. And hold on a second. So when I click OK, can you see here? It's like I am sending the random vector to run AML, and then you will automatically create out of this vector. So actually, this is more the principal way, like how the GAN and the runway ML works. But I feel like this is not quite a good way. I think we need to take advantage of like very like handy platform that is like provided by the runway ML. So yeah, everything is done. And then I just wanted to turn on the toggle to make sure to receive the generate images from the Run server. Wait a sec. Yeah, so. And then when I importing these images, the size of images around like 1024 by 1024, it's like very huge to import directly in the Grasshopper. So I just reduce this size to 100 by 100, but it's quite optional, and just do some the mathematics. So this is the showing imported images from the Run server. So what I wanted to show in here is to save these images in your the local drive, because I wanted to let you keep running the Run ML, the GPU driver, because it requires you to spend the money. So what you need to do is to set up some, wait, okay, let me create the new folder named test 4. So you need to set this the folder in right directory, and then make some the prefix of the file name. And then just there's the one thing you need to do is to make sure the range of the slide need to be the same with the number of the image output. Since we are gonna use the animate slide function, so it need to be equal to both the things, which means the length, the number of the image output is like 140, which means this slide the range need to be 0 to 139, in a total 140. After that, just turn on true to save your images, and right click and animate. There's something pops up. So you can just choose some the directory, test4, and just make sure the same size of the frame count. So let's do this. So it's just go through. So the reason why I use like this stuff is that actually the Grasshopper doesn't support some the live the for loop stuff. So I think it's like big disadvantages of using the Grasshopper. So I just use some create some the other way to bypass it. So almost done. Yeah, everything is done. And let me bring up the test 4 folders here. So actually there's the two set of the images. The first one is the actual output, and the second is just a screenshot of your Rhino viewport. And then I think you don't need to keep the screenshot, right? So let me just delete it. Yeah, and this is the output, and this workflow allow you to use the images in your local machine. That doesn't require spending any money. Hey. Oh, it's like pretty small. Okay, any questions here? If not, just let me turn off the slide because it takes like lots of time. Okay, so what's next? Just so I think you could find the Python file. Wait. Yeah, here. Name is the video frame manipulation. So what I wanted to do here in the script is to create the video out of the latent work images, or rather just extract the frames out of the video to manipulate in the local machine. So let's just unload it. Success. Okay. So what you have to do is just run cell. So the first things is to mount the Google Drive and just install some of the packages. Yep. And just a moment. And let me bring up my Google Drive. So let's do the extract frames first from the video. So I just pre-uploaded the example video in the local, not local, the Google Drive here. So you just need to get the path, the example video, copy path, and just set the same path here. And then if you run the cell, it will create the folder named the image out in the drive, because I'm already have, so just ignore this error. And then extract the video file first, and then where it's gonna be located, and the format. So it will create like the sequential named the image file. So let's run this one first. Okay, let's go. So let's go to image out. Where is it? Yeah. This guy's working well now. It looks similar, but actually it's the frames. Okay, so it's done. And then if you run this cell, it allows you to directly download all the images in a zip file. So it will save your time to download it. So just set the name of the zip file first, and then set the folder where you wanna zip, and then just put some the directory of the zip file that you wanna download. Okay. And then I wanted to create the video from the frames. So I just already have the files, and then you need to make sure the same format. So I think I use it the 5, so it need to be changed, and then just it will say in your the drive folder named the output 2 MP4. So let me run it. Okay. It's running. Okay, it's done. So let me refresh here. So you can now see output 2 MP4 that is created by the folder. The image is in this folder. But the problem is you need to make sure that some certain name formatting to create the video. So the last one, so just, and then you can just download this one. So the last one is to rename all the files in certain directory. So what you need to do is decide some the path, and then set some the prefix that will become the file name prefix, and then change like so. I'm just wanted to some different formatting. So I'm just set this the image out folder. So it has like image folder. So have like 4 lengths of the file because I set it out the formatting. Wait. Yeah, I think it's formatting 5. It's weird. Anyway, so let's change it like 4. So you can see here all this the image changed its name. Wait. Did that run twice? Wait. Yeah, so the files is, I think, yeah, I run 2 times, seems like. Yeah. Wait. So just let me just make sure, remove the image file and just create the image directory, and then re-extract the images in the directory from my video. There's yeah, image out and created like 5 lengths numbers. And if I wanted to change it to the 4 lengths, let's run it. So need to make sure it's I just want to change and length 4. So now we have like 5 lengths, but let's do it. So changed and lengths for the numbers in the file names. I think it's kind of not the real-time update. Yeah, there's some the delay when it is processed. Cool. Hey. So any questions so far? So I just introduced like how to connect the run ML from the Grasshopper side and then created some the images. But I strongly recommend you to not just use the Grasshopper the methodology that extract all the images, because it is just a random vector and then you could know how the output looks like. But if we use this the platform, it directly allow you to see the actual result. And then what I wanted to recommend you when you generate a latent video, just select some the inputs in this tab. So I just selected the export tab. Oh, it's like pretty slow. I think I am running like lots of the softwares at the same time. Oh. Actually, it was not too slow like this. Did I run the run AML? I think so. Cancel, export. Here we go. So you can just randomly just explore over this the latent space and select some the pictures you wanted to use, and you can like change some the speed and some add new. Oh, I realized how to use it. Okay. So it will gives you some the latent work directly. So I think it is good idea to use like this kinds of the function directly, since you can see the actual the image output, which means you can know what are you doing now. So the pipeline that I showed you in the Grasshopper is just to get some the random the images, which means you don't know what it's gonna give you actually. So the reason why I showed that process is just to show it could work like in this way. But I just wanted to say like it is better to use like these kinds of the workflow to make sure some the promising the output. Cool. Okay. So any questions so far? Is it good or for you guys? let me check the schedule. So yeah, like get latent work video and then extract images and then vice versa. And then just how to connect Grasshopper to Rune and just get the random style again images and then save it in your local machine to use it later without like any expenses. Okay. Can I move on for the part 2? Save resolution. So actually, we are mainly playing with the mesh. So if you are using like the 1,000 by 1,000 the images, it will generate like the 1,000 multiply 1,000 the points just from the single images, which means it requires so much like computational resources. So I just recommend you to size down a lot or the images from the 10 times 4 to about like 100 or 30 or 50. Yeah. Cool. Can I move on? Since we are gonna import lots of the images at the same time in the Rhino workspace, which it will require some very like lots of multiple times of the computational resources than the single image requires. So in here, I just only uses the 40 for the image size, but the output is like quite promising. So just you need to negotiate the computer, like what the image size is gonna be good for you and your computer. Cool. So let's jump on the stack image, the workflow. So the first thing I wanted to show is to set up the latent work images. So in folder, I already saved the latent work images I just created from the run.aml and then just extract the frames. So it's about like 350 images. I think there's some the bug here, but I think it's not a big deal, so I just keep it. So I just import or the images here about 350 and then resize it and just stack it in a vertical way. So what I have done in this process is just to import all the images step by step and then just stack it in a vertical in a sequence. So in this process, you could feel the transition of the images. I just hope to see the transition in a 3D geometry that will be the output. So I prefer for some two stuff. The first one is just uses the vertical, but at the same time, I created the curve and then wanted to make it align with this curve as the frames. So if I change it to input curve, the stacking is like changed like this from. So it depends on the concept, like how you wanted to use this process in your workflow. So you could just import the curve for the axis, and then just stack all these images in this direction. And also in here, you could, yeah, it's not for the input curve. It's for the vertical parameter. So also you can change some of the parameters to change the gap between the images and also image sizes. Cool. Let's see just one single images and how it looks like. Yeah, so if we see it in a top view, when you move the slide, you can see the latent work, like a video. Cool. And can I jump on the second phase? Any questions so far? If not, okay. Yeah.
It may be, I wonder if it's helpful for some people if you upload it in the Dropbox a sample set of images.
Yeah, it's already in there. So okay. When I unload all this grasshopper file, I also unload the latent work file that is used in my the workflow. So you can exactly will be able to create the same result as like what I have done in this workflow. Cool. Is it good for you guys? Okay. So this is from the last step. And then I just wanted to show just some of the examples, because if I do all the stuff right now, it requires a lot of the computational time. So I just wanted to show in here just some of the examples, just choosing some of the small portion of the images to help you understand how it works. So I just select some only like portion of the images, and then what the script is doing is to color 0. Yeah. So it gets the color input, and then also create some the threshold ranges. So if that the pixel within the range, we will select that points, and then this cloud of points gonna be the 3D mesh for the next process. So let me show you. So I just select these kinds of the color. So this is the actual image input. So if I increase the tolerance, the number of the points will increase. right? If I decrease, or I can change the color. So based on which color you pick and the how many threshold did you choose, it will have an effect on your the results points. So from the points, it's the same process. I will gonna make the mesh from it and then smooth it. So from this, the workflow, we will color some the points based on the input, the color, and some the threshold, and that it will become the 3D meshes. So it's like strongly related to the previous, the image, the processing, the methodology. Any question here? So far, so good. So this is why I not run all the images at the same time. As you can see here, it requires like just 5 seconds, but the creating the mesh requires like 2 minutes. So I strongly recommend you just creating this, just only the points first, disabling this the last component, and then if you find some the meaningful or some the promising some the result, the points result, you wanna go to next step, and then just enable the next component step by step. So it will save your lots of time. Because so that's why I say just use it like some the 30 image size, because the original input size is about like 124 by 124. But if we keep it, it will increase like 30 time by 30 time more, about like 10,000 times more than now, about like 2,000 minutes, just process just this single, the mesh, the calculation. So I think it makes sense for you guys. So I just pick some of the points here and then put some of the threshold and creating some of the mesh. And also I could get some of the points out of the mesh. So this is kind of the intermediate the result from this process. But in here, I feel like I wanted to add some of the texture or some of the materials. And it is like very great to get the color from the original images, because it will well align with the original the geometry shape. So instead of using some the external texture, I just wanted to apply the original the image pixel color as on the vertices color. So I think this is also makes sense, you guys. So any questions here? So last. Wait. So this is the previous result, the meshes. And then what I did here is just like the similar stuff. So just wait a minute. So I find the closest points from the original points that have the color information, and then just extract that information and then just apply this color to the mesh vertices. So find closest points, and this is the color value, I believe. Yes, this is the color value. And apply it to mesh color. So when you display the mesh edges, so actually this is not the texturized the mesh, it's just the mesh itself. So actually there are some the advantages and disadvantages of this the colored mesh, but you can will manipulate the mesh later from your taste. And so this is actual the result from this workflow, and I'm gonna show you how you could make your works better. I mean, for more the visualization stuff. So when I see this stuff, I just wanted also to use some of these the points for some the visualization effects, but it's not great idea just directly use these the points. So I just uses some the external the library. So in here, you can decide some of the different points type. And main advantage of using this the components is that you can also change the size of the points. So it looks like some of the square, but you could have some many different options. So I don't like it, but some decrease is the points and types. Oh, it's quite interesting. It makes me seem like it looks like some the shading effect in my eye. I'm not sure you agree with it. Yeah, it's pretty cool, I believe. And I also created some the component for the next step. So let's turn on this stuff. And this is the similar one that I did, just creating the clipping plane and play with it. So I created the clipping plane. So you can see here, and if I change this G direction, you could see oh. Yeah, right. Yeah. Or just you can directly move it in Rhino. So I also wanted to show some the different one. So let's keep it. And I just wanted to just bake this geometry. Oh yeah. So I bake it. Yeah. And also I wanted to make clipping plane but there's some the display setting allow you to change these colors. So for example, wait. So like this. So this is my rendering view. So go to render view, and there's the object, there's the clipping plane. So you could change the field color, whatever you want to use, like cyan. Also edge color. So you can see some different colors. So by manipulating like this option, you could make some the visualization effect. And one more things. What if let me know. Huh. Why I couldn't? It's pretty weird, but so for example, I set, hey, this the clipping plane like this way, and then change some these edges. And what if I think the problem is I already have these meshes. So if I turn on this stuff in Grasshopper and then turn up the points as well, and then I show you like this the slide. So you can make some the 3D geometry like latent work. I'm not sure how could I describe it, or just you can like just use it only points, increasing the size of the points and some the like this way, and you can like increase the space or make it smaller. Not good. Yeah, I think it's like pretty fun for me. So this is just some of the basic workflow. So you could manipulate this work. Like I'm just using some of the vertical, but you can like change it to some of the horizontal and then make some the 3D like the latent work in the from the left to right, not vertically. So so as I said before, it strongly depends on the concept and how you want to present or how you want to describe your project. So just set the strong argument or the concept, and then use this workflow in the text. Okay, so this is almost I prepare for today. So do you have like any question or like some suggestion, or just unmute yourself and just shout it out?
So I try to follow this script,
Mm-hmm.
and I uploaded my data set but I think my images might be too large, and also I didn't
Resize it.
I didn't turn off the rest of the script.
Ah,
Just crashed. So I'm worried that it's the size of my images, or it's
I
just.
think, yeah, I think that's because the size is too large. So I think I will re-upload the script that all the components are disabled. So you just run the script and then just enable the component just step by step, and then figure out like where the problems take place, and then change resize your images. Yeah.
Just because some of my images were like, most of them were like 1 MB, but some of them were like 2 or 3, and I don't know if that's too much. Some of them, I mean, all of them are more than 1024.
Yeah. So that's why I strongly recommend you to resize here.
Oh, okay.
Yeah. So actually, the original input size is about like, I'm not sure, but it's about like 1024 by 1024. Like it's a regular the large image in this deep learning model, but this the 3D that the computation requires some lots of the computation resources. So I just directly do the image resizing before converting it to the mesh geometry.
Right. Okay. Yeah, I'll try that.
Yeah. Actually, yeah. So I think I don't need to upload the disable file. Just use this script and then make sure before you change this path, you just disable the older component and then change your path. I think
that makes sense.
it works for you.
Okay, thank you.
Yep. Okay. Any other questions? Because I also know I go through lots of the image, the manipulation, the process, and some the 3D geometry, the processing. So you need some the time to digest it, right? But just feel free to ask any question or some. And if you wanted to some the functions to improve the quality of your work, or if you need some the specific workflow out of this the basic workflow, just feel free to ask any question or some the suggestion or anything. So in this stage, I wanted to emphasize something that is, so we mainly in the process we mainly use some the stacking. So I'm wondering how the stacking could be described in the concept of the project. So the reason I stack it is that I believe it could represent some the timeless. So I'm not sure it could be applied to the project, but you could the 3D geometry that represents some the timeless as goes up, or some the horizontally or whatever. But I wanted to emphasize on the concept, like how you could play with the latent work, or some the different elevation up, not elevation, some different output out of your the style again, the model. Okay. I believe you guys are good or need time to do it. Cool.
Yeah, honestly,
So-
I was just following you, so I guess it
Yeah,
will
yeah.
take
No.
time to work on by ourselves, and then if it's possible to give some feedback later. So
yeah, sure.
it will be convenient.
Since I also spend like lots of time to like make this kinds of the workflow, because actually there are like some lots of the problems, like, and then I need to bypass like something like sometimes the filtering the points inside or the outside mesh is like very tricky. So I need to try lots of some different method that make it work. So just feel free to ask any like question later, and post some the words in Discord channel or some the tech support if you have any question. Okay, so I think.
Sorry, and maybe I'll just ask. Because I know you said it, but I think I got lost in that moment. When you use the collab script for renaming those images, what is the purpose of that? Why do we do that?
So actually, if you already made some so I just assuming that you already created the multiple latent work images, and then in order to make those images to the video, it requires the certain name formatting. So the renaming is mainly for just changing the files that you already made.
Oh, for the sequence.
Yeah.
Okay.
Yeah.
Okay, got it. Yeah.
So it's like I prepare like lots of the handy workflow, like you could extract all the frames or you could make a video and simply download it in the Colab, and you need to like pay for anything because you can take advantage of the Colab thanks to Google. And and then even you can rename it, because I just wanted to save your time and let you more focus on the work, rather the focusing on the technical issue, because I also like spend lots of time to solve lots of the technical problems in my life actually. So we are in very like limited time. So I just want to help you guys as much as possible I can. Okay, so my turn is almost over. So I'm let George hijack.
Yeah, just to add to that last comment, definitely feel free to use the images that Dongyong put up, but we do encourage you to use the latent walk videos that you've all created.
Yeah, sure.
So that all the outputs are different. So for that, you might just need the first part of the collab, but feel free to use the other parts as well.
Yeah, so the most important thing is to know and understand what you are doing and use the preset, the script or the grasshopper definition for the work. Cool.
And we'll cover this a little more later, but we will ask that you guys present a very short update of some of the outputs you've made just tomorrow in a few minutes, and we'll cover this after a small debriefing Runjia is going to give us for tomorrow.
Alrighty. So yeah, now since we are having like a workshop for tomorrow for the 3D CAN, I'm just gonna briefly go through some of the pre-processing of the data set that for tomorrow's section. And just to make sure you have like the adequate amount of like 3D models so that you can actually do the training tomorrow. And most of the contents can be found in the Dropbox folder under the handout 1. So yeah, I'll just briefly go through what will be like the process for running the entire workflow. So first of all, yeah, you have to make sure that you have the correct folder structure inside your 3D dataset. Yeah, and I have put an example directory under the Dropbox Machine Intelligence 3D Data Collections 3D and RenJS 3D dataset. So basically, what you have to do before actually do the processing is to have 3 folders, named in the form of source, which you can put in whichever format of 3D model that you like. Yeah, but please do not use DAE files since that's not supported for Rhino import. But Rhino supports most of the file formats, like for the 3D representation, such as the SketchUp model, the FBX format, and the 3ds format, and the OBJ formats, as well as some of the DWG formats from Autodesk. So this basically you can store in any type of 3D files that you can do here. And so this is just the raw file that you collect. The one thing you have to make sure is that they do not have to come with the same unit exactly, but you have to make sure all of your files are on the correct scale. So for example, you cannot have a Villa Savoy measures 10 centimeter by 10 centimeter, but rather it's like a actual architecture scale of objects. So yeah, just make sure all of these things are on the same dimension, and then you can just proceed with the next step. So the next step is once we have those different formats of the 3D files, we're gonna transform them into the same unified format that we're gonna be used for the next voxelization process, which we call the OBJ files. So now you can see I have the empty OBJ files in the folder directory, and I'll be using the provided code for like running the format unifying process. So let's just open Rhino and Grasshopper. And we have provided a script for you to pre-process the data under the Dropbox link. There are 4 toolkits, these 3 toolkits, and it's called Rhino batch conversion.gh. So once you open the GH file, you can see that that's a very simple Grasshopper file, contains 3 inputs, like a debugger for printing the file processing process, as well as a Rhino Python scriptable object. So if you click into it, it contains most of the scripts. So we're mainly using Rhino script syntax as the processing API. And this takes charge of the actual import of each of the 3D file, as well as performing some data augmentation for your 3D models. So what you have to do here, sorry, I should have turned this into false. What you have to do here is just to replace these like 2 input boxes with the actual repository where your data set resides. So for example, it's very simple to do that by just clicking to the address block of your folder. So mine is located in the data collections 3D, and this is where the source folder is located. Just copy and paste into the first. So that's where the input for the source folder path, and the target folder path is the OBJ files. As you can see, I just ran the script for once, and it's already there. I'll just delete and run that again, just to paste it into the chat. Yep, and then you just click run script, turn that to true, and Rhino will just automatically help you perform the unifying of the file formats into the OBJ formats. It's gonna take a while, I think, if the files that are imported is really large, but it's gonna be still be very efficient. So as you can see, I have like around 8 objects in my original folder. And essentially we are doing the similar stuff for the 2D dataset augmentation for 3D dataset augmentation. And yes, just to make sure that you have your z-axis up in the SKP and 3DM and all the major formats. But for OBJ, you might want to, it's a little bit tricky if you are creating the OBJ files. Yeah, because it has a y-axis up definition. But you can inspect it manually when you import the OBJ files into Rhino, whether that's flipped or not. So once we have all this OBJ files here in the folder, what we're gonna do is that we're gonna perform a simple voxelization process for all of the objects. So we just delete all of them, and if you do not see this, it's very simple. Just perform a view group by type, and then you can see all of your OBJ files inside the folder. So just to make sure you copy paste the files instead of like just performing the operation inside the folder directly. You copy paste the OBJ files first in the binbox folder, and then we're going to delete it once we have everything. Yep, and then what we're going to do the next is we just voxelize all these 3D models using an open source voxelization process called binvox. So basically, you copy the binvox.exe into your data collection folder in the binvox folder, where we already copy paste all the OBJ files. So now it's here. We have the binvox.exe here, and then we're gonna do the file processing using the command line tools. So how we do that is just we type command prompt, and then we're just gonna have the command prompts here. So first we have to go into the folder where the OBJ files are stored. So to do this, we just use CD, and you copy paste Ctrl+C, Ctrl+V, copy paste all the address where your OBJ files are located, and we're going to perform the voxelization process. We just use CD, which refers to current directory. So it's current directory, the current folder, and then you're going to notice that you're going to have a different, directory on at the front of each line. So the next step we're going to do is just that we're going to binvox this file. Since we have the binvox.exe in our folder, you can just use the binvox.exe in the command line. So basically, you can just very simple just by typing binvox, and that process like a file individually. So for example, if we want to process the cruciate/0.obj, we just type binvox. C refers to just the Z buffer based covering methods. D means dimension. So if we want a 64 by 64 voxel, a 64 by 64 by 64 voxel, which is the default for 3D neural network, you just use the type 64 here. And T means whether you want to, which type of voxelization you're gonna use for representation. By default, we use binvox. So just T binvox, and put your name file here. Just cruciate/0.obj. You can also copy paste the file, and then you're gonna do the voxelization for you. So, but we have so now you can see we have the binvox file in the folder. It's called cruciate.binvox. But how can we do the voxelization for all of the file in the folder? Well, so that's pretty simple. But by using some small tricks of the Windows command lines. So it's basically you just use this syntax for files p/p/m obj.c and blah blah blah. So it's very intuitive. Just make sure you are in the correct folder, and you copy paste the line into the command line prompt, and then you press enter. Boom, that's it. So the computer is gonna perform the voxelization process for you. Yes, some of the files can be slow if your files are really large. Yep, but eventually you're gonna get all of the binvox files which is the voxelized version for your OBJ files, and we're gonna use those binvox files as the training data for our 3D GAN tomorrow. So just make sure you have all the 3D models ready for tomorrow's training, and since we're gonna and put them in the correct folder structure in the Dropbox folder. So yeah, it's under Dropbox 3D data collection 3D. So rename your folder name in the format of first name, last name /3D/dataset, and do the and then create the correct folder structure of binvox, source, and OBJ, and just put your files in here. So yeah, that's gonna be all of the part for the data processing. So after you have all your binvox files in the folder, yeah, which I think is gonna be really soon. You can delete all of your OBJ files, just left all the entire folder with only binvox files. Yep. So one reminder that we have, and also that's written in the handout, is that first we think that it will be easier for the 3D GAN training to converge if your objects are on the similar scales. So for example, all of them are just all like single family houses, or just all of them are museums, but do not mix single family houses with museums, because it's going to be really hard to converge because they have really different scales. Another reminder, as we think, is that it would be better if to use smaller or models that does not have a really huge detail. So we're going to be using 64 as the dimension for voxelization for the training tomorrow. Yeah, so if you have a really detailed model, it may not be able to capture all the details that you want. So 64 is like a really rough like representation for 3D models. And that's what the Google default GPU computational power allows. So yeah, and that's it pretty much for the dataset collection. And we're going to use this dataset collection as a crowdsourcing efforts towards training the 3D GAN for different objects as a collective output for the workshop. So make sure that you upload your 3D dataset into the correct folder with the correct direction name, correctly labeled, like by the start of the workshop tomorrow. So that's it. Does anyone has any questions or problems running the script? So make sure you use a Windows machine for this. Otherwise, like the command line part might be like have a very different syntax, or you might experience some issues that we have not foreseen using Mac system or Linux. Yep. Alrighty, if no one have any questions, I'll just give the stages back to George.
All right, thanks for that, Runjia. Maybe I'll give some closing remarks. Share my screen again. All right, so just a recap on where we are. We're end of day 2. Hope you enjoyed this workshop and the talk by Nono. Just a heads up, tomorrow we'll be having Jia Zhang. She's a Harvard GSD Irving Fellow who has considerable experience in machine learning, and then we'll have a 3D GAN workshop. I do want you all to pay attention to the final presentation, which is going to be on the last day. So with that in mind, we do urge you all to use the work sharing to share your work, but more importantly, the team forming channel. So by the end of today, let me go back. We have I'm going to share this in the Discord in, say, announcements. In the same survey link you guys all did at the beginning, there's a second tab on the bottom. It's called Team Forming. There are 10 teams. We urge you to form teams of 2 or 3. And you can use the survey to kind of get a feel for each other, or just reach out on the Discord. But it's a great way to meet other people and discuss ideas even outside the workshop. If you don't form a team, we will pair you by midnight tonight Eastern. So we hope you have the chance to join someone. So 2s or 3 maximum. So for any general tech support, again, use the tech support channel. And regarding tomorrow, after Gia's presentation, we will have a chance for approximately just a few minutes each. These can be individual. It might be a bit short notice to start working as a team. If you do reach out and form a team now, we're happy for you guys to just share a few slides. It's more of an informal presentation or project update just to share some results, share your screen for 2 or 3 minutes to see what you've been doing. And this will also help everyone kind of start building narratives or projects they would like to explore in the final project. Now in the final project, we're keeping it open for you to choose a specific route you want to choose, and maybe for tomorrow it might be, we don't want it to be too much of an overload. So you can, for example, from today you can pick one or two of the definitions and see if it works with your latent walk, or use the given images. Again, if you have any questions or anything regarding these, feel free to reach out. So tomorrow, as a recap, 2-3 minute each, or in pairs. That's pairs or groups of 3. That's completely fine. Just a few slides, or 1 or 2 slides, just to show animation or latent walk, just a brief overview of your interests. And yeah, that's the end of today. If we have any last questions, we look forward to it. And just a final note, we have just received confirmation from Jose Luis Garcia del Castillo Lopez, quite a long name, that he will be actually available to join us on Thursday. So we will be having his Monday talk on Thursday morning, and right after that we'll have those group meetings and tutorials. We can have them for 15 or so minutes if you guys want it, so we can discuss more on an individual basis, or do a tech support for those who need it.
Yeah, I just thought of something else. Runja, you showed a script for augmentation, right? For making more models.
Yep.
Is it expected that the models rotate like upside down, or they're going to rotate, right? Is that expected? Because if you have a house, then maybe it's going to be like upside down. Is that?
No, you're not going to rotate upside down. You're just going to flip around the z-axis.
Oh, z-axis. Okay, then that's fine. Okay, yeah.
So, but you have to make sure that if you're using a house, like, make sure your model is not upside down when importing the file. Yeah.
Okay.
Great.
Oh yeah, maybe just a quick announcement. I think the Digital Futures organizing committee is just asking us about any work in progress sharings of your work. So if you have any concerns of sharing your works to the public community of Digital Futures, please just direct message us in the Discord channel. Yeah. Otherwise, we just will be sharing some of the work with the entire community of Digital Futures, and that's it.
All right, we'll stay on the call for another few minutes, but that's a wrap. Thanks, everyone, and see you tomorrow.
Thanks. Thank you.
Okay.
See you tomorrow.